Hello, everyone. Thank you for joining us this evening for the webinar Hot Stuff, Electrifying Water Heating, Cooking, and Clothes Drying. My name is Jason Clay, and I'm joined by my colleague Matthew Douglas May. And we're from Electrify Everything Minnesota, which is managed by the Center for Energy and Environment and supported by the city of Eden Prairie, Bloomington, Edina, Minneapolis, St. Louis Park, Rochester, and Hennepin County. And the goal of Electrify Everything Minnesota is to support the gradual electrification of single-family homes through education and providing resources to residents of Minnesota, as well as providing one-on-one support through our Electrify Everything advisors. So here's our agenda for this evening. We're going to start off with our presentation, go over a few items, and then at the end, we'll have about 10 to 15 minutes to get some questions asked and be able to provide answers for any lingering questions you may have. A few housekeeping things. Please put your questions in the chat. Matthew will be monitoring the chat as we go along. Any clarifying questions you have throughout the presentation, feel free to drop them in there, and we'll touch on those as we can. Larger, broader questions, we'll save those to the end to the Q&A. The slides that you're seeing tonight, I'm going to be sending them out in an email as well as some additional resources to you after the workshop. So you will have access to all of these slides, as well as the hyperlinks that are in the presentation itself. So some of you may have attended our first webinar last week where we talked about air source heat pumps and some of the steps and benefits to home electrification. And we're going to go over a few of those things quickly here. So, does electrification really reduce carbon emissions? Luckily, in Minnesota, we have a clean energy bill in place that requires electric utilities to provide 100% of energy they produce from carbon-free sources by 2040. And Xcel Energy is on the path to reduce its own carbon emissions by 80% by 2030 and achieve 100% carbon-free by 2040. Currently, as of 2024 at least, Minnesota generates 54% of its power from carbon-free resources. So as you can see, by electrifying, we're really building up the momentum to get off fossil fuels and have carbon-free energy in the state of Minnesota. So why do we want to electrify? To start off with, using electricity is safer. A lot of electrical appliances will remove some of the common hazardous air pollutants that are associated with gas equipment. When we use those in our homes, that can be carbon monoxide, as well as other hazardous air pollutants, as well as just combustion hazards. And along these lines, I was tabling this weekend and spoke to someone who had a gas stove who actually ran into an issue with her gas stove where when she was leaving for work, her purse accidentally got caught on one of the knobs, left the gas on all day. And so her neighbors were worried about the smell of gas fumes. So that's just one of the things by switching from, say, a gas stove to an electric stove. You can have the peace of mind knowing that that's not going to be a problem. So here's some of the key projects for electrifying a single family home. Last webinar, we talked about weatherization, which is essentially insulating and air sealing your home, making sure that these electric technologies work to their highest efficiency level. And we also talked about heating, HVAC systems, air source heat pumps, and utilizing energy efficient air source heat pumps as your heating and cooling mechanism for your home. Today, we're going to talk about electrifying appliances. So we're going to cover water heating, clothes drying, cooking, and electrical panels. So the reason we focus largely on air source heat pumps and heating is because, as you can see from this chart, heating makes up a large proportion of our energy usage here in Minnesota compared to the national average. In Minnesota, the average is 72%. The large is our energy usage comes from heating, whereas 39% nationwide. And that's primarily because, as you're all aware, we have a longer cold season than most states. And so that plays into why we use so much of our energy to heat our homes. So by reducing how much heat is required to heat our homes in the wintertime, we can take a huge chunk out of our carbon footprint and the largest source of energy consumption, again, which is heating. So if you wanted to type in the chat quick, Matthew will have a look. What are some of your motivations for switching to electrical appliances and what brought you here this evening for this webinar? Okay, and I'm going to hand it off to Matthew to start us off with heat pump water heaters.
Awesome. Thank you, Jason. And yeah, folks, we'd love to hear what your motivations or goals are. So throw those in the chat as we're talking here, and um, we'll jump on into water heaters. So, like Jason mentioned, heating is the biggest source of energy use in a home, but water heating is the second biggest source of energy use in a home. So, focusing on efficient electric water heaters, which are heat pump water heaters, is a really powerful way to reduce your emissions, and save energy. Next slide. So, what are some of the benefits of heat pump water heaters? A big one is that because they're electric, they produce fewer emissions. Next, they eliminate combustion gases from water heating in your home, which can come with those health benefits. They're up to 3 times more energy efficient than traditional electric water heaters. They're super duper energy efficient, and we'll tell you why. So that's really a big one. You can save a lot of money on your bills if you're switching from an electric one, an electric resistance water heater. Heat pump water heaters have a dehumidifying effect, which can be great for humid basements. And your bills will have a comparable cost with traditional gas models and can save a lot of money compared to traditional electric models. Next slide. So how do heat pump water heaters work? Well, last week we spent a lot of time talking about heat pump technology and how it moves heat from one place to another. Uh, these water heaters use heat pump technology and they pull heat from the air around them and put it into the water. And the basic principle, the physics principle, is that heat goes to cold. So they move heat from the air into the water, and then they expel cool, dry air. And next slide. This diagram shows how that works. So on the left side here is the top of a heat pump water heater. That is the actual heat pump part. And it draws in warm air with a fan. It blows that warm air over cooler evaporator coils, which absorb that heat. And then by absorbing that heat, they then expel cooler air. Then if we look on the right side here, that absorbed heat goes down into the water tank through those red coils and distributes the heat into the water that way. Those little yellow elements in there are electric resistance booster heat that can kick on when extra heat is needed. So that's the basic principle. It's pulling heat from the air and putting it into the water through refrigerant coils. Next slide. So when you're thinking about upgrading your water heater, the big question is, will I run out of hot water? The worst thing is being in the shower, you're all sudsed up, and you run out of hot water. So a really important question to ask is, will I have enough? The short answer is that heat pump water heaters provide roughly the same amount of hot water as other models. So this top row here shows that you'll get about, between 2.75 and 3.25 consecutive showers with a heat pump water heater, compared to a gas tank of about 3.5 showers and an electric resistance tank about 3.25 showers. So roughly the same amount of hot water. And if we look down at that first hour rating, we see that the amount of water delivered in the first hour of, say, taking showers is the same as a gas tank. And then the key difference is this bottom row, the recovery rate. This is how much water the water heater, or how many gallons of water the heater can raise by 90 degrees Fahrenheit in an hour. You can see that it's a little bit lower than a traditional gas tank, but higher than an electric resistance tank. So overall, heat pump water heaters are competitive with supplying enough hot water to your home. Next slide. Here's an estimate of, based on your household size, what size of a tank you need. Because really the sizing is the big thing you have control over to make sure you've got enough hot water. So if you have a family of 1 to 2 people, a 50-gallon heat pump water heater is great. 2 to 4 people, 65 gallons, and 3 to 6 people, 80 gallons. This is, of course, a rule of thumb. Some families use more water than others. Some people wash their clothes with cold water, other with hot. So taking stock of your current system is the best place to start. Next slide. So when thinking about sizing, if you're going from a gas water heater to a heat pump water heater, it can be a good idea to go up one size. So say you have a 40-gallon gas water heater, getting a 50-gallon heat pump water heater is a great way to get, roughly that same amount of hot water that you're used to. If your house includes children or teenagers, we all know that teenagers love to take long showers, and it can be a good idea to size up if you have kids in the home, or if you expect your occupancy to grow in the next 5 years, because heat pump water heaters typically last around 15 years. Next slide. So most heat pump water heaters are 240 volts models. So they require a 240 volt circuit and wiring running to them. However, in recent years, 120 volt models have entered the market. And these are an interesting option to families because they can plug into a standard 120 volt outlet and don't require running new wiring or potentially upgrading your panel to use them. However, these models do not have that electric resistance booster heat in them. So they have a much slower recovery rate and provide less hot water less quickly. So these are really best for small families that don't use much hot water. Otherwise, that 240 volt option is what we recommend for most families. But as Jason will talk about later, panel upgrades and wiring can be expensive, so this can be a good way to avoid that. Next slide. So the next question is, where should I have my heat pump water heater installed? Next. And it really comes down to location, location, location. There are 3 main factors when thinking about where to put your heat pump water heater. One is the air volume around the tank. The other is comfort, and the other is maintenance. Next slide. So thinking about air volume, because heat pump water heaters are pulling in heat from the air around them and then expelling cooler air, they require a certain amount of air volume around them to work efficiently. If they're in too tight of a place without that airflow, they can't pull the heat out of the air. So it's recommended that heat pump water heaters are installed in a room between 450 and 700 cubic feet. 700 cubic feet is like a 8 by 10 room with an 8-foot ceiling. So still a pretty small space. That's what you're seeing in this picture here. And that's a room that would have a closed door and be isolated. Next slide. If you do not have, say, a utility room that big, or you don't have space in your home, you can still have a heat pump water heater. You'll just need to make sure there's airflow. There's a couple ways to do that. One is with a louvered door, as you can see here. It's important to have a louver on the top and the bottom so that warm air can be drawn in and cool air can be expelled out the bottom. Another option is ducting from one room to another inside the house. You don't ever want to duct a heat pump water heater outside of your home. Um, and so this is great, even if your heat pump water heater is in a closet or a smaller space, working with a good installer can make that happen. Next slide. Another consideration for where to put your heat pump water heater is maintenance. Heat pump water heaters have a filter on the top because they pull in air, and that air goes through the filter. So you need to be able to remove that filter from the top. It's kind of like pulling up a piece of toast out of a toaster. It usually goes up. And heat pump water heaters tend to be 5 to 6 feet tall, a little bit taller than traditional water heaters. So it's important you have enough clearance in your basement above them. Most houses do, but it's a good thing to check. Next slide. And here's another question. You've heard me mention a couple times that heat pump water heaters pull in warm air and expel cool, dry air. But will that cool, dry air leave my house feeling cold? Next slide. This is a really valid question we get frequently. And the answer is that a heat pump water heater will lower the temperature of the room they're in about 1 to 2 degrees while it's running, which is about 3 to 5 hours a day. So most folks, say you're in this picture here, you're doing laundry, you might feel a little draft, a little 1 to 2 degree drop if you're in the space while the water heater's running, but otherwise it's usually not noticed. So if it's in a basement or utility room, no one will really ever even think about it. The only consideration here is to make sure it's not blowing, say, like straight to your reading chair in the living room or into a bedroom where someone's sleeping if you need to duct it, for example. So yeah, for the most part, we've found really most people do not find this to be a problem. Next slide. Another consideration is how much noise do heat pump water heaters make? What does that fan that pulls the air in, what does that sound like? Next slide. And I'm actually going to pause quick because I just saw a question from Andrew. How often do you need to replace the heat pump water heater filter? That's a great question. So heat pump water heater filters are cleanable. It's not like a furnace filter where you have to get a new one every time. And typically recommend every 1 to 3 months that you pull that filter out, clean it off with warm water, dry it out, and then put it back in. Okay, back to noise. So how much noise does a heat pump water heater make? And the answer is they're pretty quiet. At their loudest, they can sound like a modern dishwasher. So, if this heat pump water heater is installed exactly like in the wall right across where your head is, where you sleep, you might hear it. But again, if it's down in the utility room, most people don't notice it. Here's a scale on the right side here, kind of a comparison of how many decibels a heat pump water heater makes while it's running. And it's, lands between a soft whisper and a normal conversation 3 feet away. But again, the dishwasher or refrigerator is a good estimate. Next slide. So those were some of the key differences between heat pump water heaters and traditional water heaters that you can ask your contractor about when you're looking to install one of these. And really the key questions that we recommend asking contractors focus around sizing and location. Next slide. So the first question we recommend asking is, how do you determine what size water heater my household needs? What the contractor should do is ask you how many occupants are typically in your home. They should ask if there are currently any issues with the hot water supply if you're running out. Also ask about your hot water usage patterns. For example, does everyone take showers consecutively in the morning, or is it spread out? And then it's also very common for contractors to recommend sizing up, like I mentioned, because going up one size from your gas water heater to a heat pump water heater is a great way to get, pretty much the exact same water performance. What a contractor should not do is just say they'll do a one-for-one size replacement and kind of dismiss this question. It should be, a good conversation that they can have with you. Great. Next slide. And I see a question from Lee. I'll answer that question at the end of this section here. So the next question is about location. How do you determine where to install my heat pump water heater? What the contractor should do is talk about air volume requirements for the unit, assess the location of the current water heater. They should ask about the frequency of occupancy of certain locations to understand if there will be any comfort concerns or noise concerns there, and then also describe how location can affect comfort. So what they should not do is say they'll just put it right where the old one is without really thinking about it. It is also important though if a contractor says, no, we can't do a heat pump water heater because the space is too small. It's important to ask if they can do ductwork or install a louvered door, for example. So it's good to be ready to ask those questions as well. Next slide. After your heat pump water heater is installed, it's great to ask the installer to walk you through the operational modes of the heat pump water heater and show you how to find the filter and clean it. Every water heater has its own setting, so it's really helpful if the installer can teach you how to use it. Next slide. So who do I go to get quotes for heat pump water heaters? We had the same question a couple of years ago because we were finding that not all HVAC installers and plumbers do heat pump water heaters, and we want to make sure that residents can go to folks who are experienced and knowledgeable about heat pump water heaters and can get you good answers to your questions right away. So we created the Heat Pump Water Heater Installer Network. And to join the network, contractors must complete a training and verify their experience installing heat pump water heaters. So this is a great place to go to get quotes and work with experienced contractors who can figure out the best fit for your home. That said, we still recommend asking these contractors the key questions we mentioned, and we recommend getting multiple quotes to compare options and get different pricing estimates. Next slide. So another question, will heat pump water heaters save me money and or energy? Next slide. So there's a couple of things to consider here. You can base this off the energy guide, that yellow label on the heat pump water heater. And then you also need to think about, are you comparing this to an electric resistance water heater, a gas water heater, a gas tank water heater, or a gas tankless water heater? Next slide. And the quick answer is that compared to a gas water heater on the bottom left here, a heat pump water heater can save up to $100-ish or come out about break even. So if you're switching from gas to electric with the current price of gas and the current price of electricity, you can expect your bills to remain the same or save $50 to $100 each year. If you're switching from an electric resistance water heater to a heat pump water heater on the top there, you can see your annual bills might go down from for over $400 to in the $175 a year range. That's because of the huge efficiency improvement that a heat pump water heater provides. So you can expect significant savings there. And then again, compared to a gas tankless water heater, you can expect your bills to remain the same or be a little bit lower. Next slide. Looking at the lifetime costs of water heaters, this is the Rocky Mountain Institute's Green Upgrade Calculator. And they use some estimates to calculate the lifetime cost for purchasing it, maintaining it, and the energy costs. And we can see that a 40-gallon gas tank compared to a 50-gallon gas tank compared to a 65-gallon heat pump water heater has pretty much the exact same lifetime costs in this scenario. Next slide. But another big reason to get a heat pump water heater is reducing your carbon emissions. Here's one estimate, again from the Rocky Mountain Institute, that a heat pump water heater at today's electricity fuel mix will save about 13 metric tons of CO2, which is pretty significant. And as Jason mentioned, Xcel Energy is on the path to 100% carbon-free electricity, which reduces those carbon emissions even further. So if you're looking to reduce your environmental impact, getting a heat pump to heat your home is the biggest thing you can do, along with insulation. And then the second biggest thing is getting a heat pump water heater. Next slide. So how much do heat pump water heaters cost upfront? We see on average quotes coming in between $4,000 and $6,500 installed cost. This you might get quotes outside of that range, but this is typically what we're seeing. And the good news is that there are some good incentives available. So Xcel Energy has a up to $500 rebate for a heat pump water heater. The federal 25C tax credit would provide up to $2,000 for a heat pump water heater. And even with some of the federal uncertainty that is happening now, tax law states that any changes made don't go into effect until the next year. So a heat pump water heater installed this year, we're quite confident would still qualify for this 25C tax credit. And then expected later this year are the federal IRA rebates, which would provide up to $1,750 to income qualified families. So all of these can stack to save quite a lot of money on installing a heat pump water heater. Next slide. All right. And before I pass it back over to Jason, I just wanted to answer Lee's question. The question is, if the expelled air is dry, is there condensation somewhere during the summer? That's a great question. Yes. So the heat pump pulls the warm, moist air over those evaporator coils, and the moisture in the air gets condensated, and then it goes into a condensate tube to a drain. So it's just water pulled from the air, and it'll go to a drain or a condensate pump. And then you don't have to buy replacement filters for heat pump water heaters. They just come with a one that you can just clean yourself and use for usually the lifetime of the water heater. Yeah, Fred, that's a great question. How does a heat pump water heater compare to an electric car for CO2 emission savings? I don't have those exact numbers in my head, but I'll see if I can answer that at the end of our webinar. All right, over to you, Jason.
Thanks, Matthew. So now we're going to talk about induction stoves and heat pump clothes dryers. So many of you may be familiar, have heard about induction ranges. They're pretty common nowadays. You'll see them a lot. And that's primarily because they're a great solution to your having your cooking needs in your home. They're energy efficient, they're electric. Um, the the significant thing about induction stovetops are that they heat the pan and not they're not like a gas stove. They're not working by combustion. They boil water very quickly in comparison to, say, a gas stove. Um, I've seen it about 2 minutes versus 8 minutes on a gas stove. There's with induction stoves, there's precise temperature control, significantly better than, say, a heat resistant element electric stoves, and sort of comparable or better to the control that you would have using a gas stove. They're really easy to clean. If anybody's used electric resistant stovetops or gas stovetops, they got a lot of nooks and crannies. They can get food and other debris down. They can be difficult to clean. With an induction stovetop, as you can see from the picture, primarily a flat surface, very easy to clean and maintain. And as I had mentioned earlier, gas stoves in particular emit hazardous air pollutants in the home, even when they're not on. So having an electric stove, an induction stove can significantly reduce the indoor pollution in your home. And along those lines, traditional electric ranges are great options too. Induction stoves are a little bit better, and they're kind of a novel technology, and we'll explore them a little bit further. Range, safety, and indoor pollution. Again, this is going back to what I mentioned earlier. Gas stoves, they release hazardous air pollutants into your home, whether they're on or not. This mainly consists of nitrogen oxide and carbon monoxide, but you can also find other hazardous air pollutants in your home, like benzene. They can leak even when they're not on. And as I had mentioned earlier, there's kind of safety issues with gas stoves. You can accidentally leave them on, releasing gas into your home when you're not around. Children living in households with gas stoves are over 40% more likely to have asthma. And the Rocky Mountain Institute, which we referenced earlier, um, found that gas stove pollution causes roughly 12.7% of childhood asthma in the United States. So important health considerations to think about if you do have a gas stove, and how induction stoves to sort of mitigate those concerns if you have one of those in your home. So how do induction stoves work? Well, they're very neat technology, and basically induction stovetops work through an electromagnetic field, which transfers energy directly to the cooking pan through that field. And you can see on the graph image to the right how these work. Generally, the induction stove creates the electromagnetic field. It's transferred through the ceramic surface, and it works with magnetic cookware to heat your food. So what sort of things can you expect with an induction range? One consideration to think about if you are going to switch to an induction stovetop is that the cookware you use needs to be magnetic. And you can see this little icon image next to the stove on the right-hand side. That is an image you'll often find on the bottom of pots and pans, and that indicates that they are conducive to working with induction stoves. And these are generally, they're going to be cast iron, enameled cast iron. You'll have enameled cookware with cast iron cores. Uh, Cookware that's not compatible is going to be your aluminum and copper pans. And one easy way to check and see if your current cookware would work on an induction stove is just to use a magnet. The magnet sticks to it, more than likely will work. The electromagnetic field may not be safe for people with pacemakers, so that's something to consider if you are looking into an induction stove. Another thing that people new to induction stoves run into is that the heating can be very quick. So you might have a tendency to burn things right off, but of course it's just a learning curve. It's something that you'll adapt to and adjust to over time. Another consideration for induction stove is that they will require a 24-volt outlet typically, and I'll go into talking about electrical panels a little later, why that's an important consideration to keep in mind. So along those lines, the heat pump ventless clothes dryers have similar benefits to other heat pumps. They're very energy efficient. They're going to be gentler on your clothes. One really awesome perk with the heat pump dryers is that they don't need venting, so it gives you a lot of flexibility of where you locate them in your home. They are up to 2 times as efficient as traditional electric dryers. And of course, traditional electric dryers are good too. It's a great way to reduce your fossil fuel use. Um, and but the heat pump dryers, they're great technology. Definitely something to consider if you're looking into buying a new dryer. So how do these heat pump dryers work? Again, as Matthew mentioned with heat pump water heaters, and if you're at our previous webinar, we talked about air source heat pumps. They work with heat pump technology. And the gist of it is that it pumps heat from one area to another. And in the case of the heat pump dryers, it's going to absorb hot air, ambient air from within your home. It's going to recirculate that hot air to draw away moisture from your clothing. It's going to deposit, the evaporator will condense that cool or moist air and deposit that water into condensate. Like with the heat pump water heaters, that can be in a tray, or that condensate can end up going into a drain. You can see with this graph image to the right, kind of how it functions. It's a pretty simple technology, but again, it works on that heat pump premise, and it is along the lines with all the other heat pump technologies. It's very energy efficient. So what can you expect with a heat pump dryer? One thing that people often bring up is that there's going to be longer drying cycles. They're typically 45 minutes to an hour and a half. Um, but if you're not doing anything, that's usually not an issue for most residents. You don't need venting, as I mentioned earlier. That's really great. It gives you a lot of flexibility again to where you can place that heat pump dryer in your home. It does require a condensate system, as I had mentioned, which could be a pan or a drain. It's just removing that moisture from your clothing. It needs to be deposited somewhere. So that's something you need to consider when you have a heat pump dryer. There's going to be multiple filters to clean. With a lot of dryers, you're familiar with the one lint filter that you're frequently cleaning out. With heat pump dryers, there's going to be multiple of them. So again, that's another consideration to think about when you're thinking about the maintenance for a heat pump dryer. Typically, heat pump dryers are also going to require a 240 volt outlet as well. So I'm going to hand it off to Matthew, I'm sorry, and we're going to talk about what to expect when you're installing an electric stove or dryers in your home.
Great, thanks, Jason. Next slide. So when you're thinking about installing a stove or a dryer, and thinking about going from a gas version to an electric version, an important thing to think about is that you will need a 240 volt outlet to plug that new appliance into. You'll also need to cap the existing gas line because you won't be using that anymore. So typically an electrician, HVAC technician, or a plumber can do that work for you. They can run new 240 volt wiring to your kitchen or your utility room and then cap the gas line. If you already have a 240 volt outlet in the space or in that room, you're good to go. And then another consideration that Jason will talk about is making sure you've got enough space in your panel to add that new electric load to it. So this is usually something that is good to take care of before the retailer delivers it to your house. Next slide. So a common question to ask a retailer is, next slide, is what do your delivery and installation services include? And I should mention that the most common way to get an induction stove or heat pump dryer is really through traditional appliance retailers, those, big box stores that do a lot of these. They have a lot of great options, knowledgeable salespeople, and can help you find the option that's best for you. One thing that most of these retailers do not do is the electrical work and the gas capping. So it's important to ask what their delivery and installation services include. And what they should do is clearly outline what it does include. It might be, they deliver it to your home and bring it into your home, put it where it's going to go and plug it in. That's the most common. It's good to ask them if they do electrical work or gas capping, and they should be upfront if they do or do not. One thing to look out for is if they try to talk you out of your gas appliance, it might be worth going to another store, getting some other opinions, because that salesperson may not be as knowledgeable about electric technology. Next slide. And then, again, the question is, how much will these cost? Typically, induction stoves cost anywhere between $1,000 and $4,000. There are some below that range, and then you can kind of go as fancy as you want with kitchen stuff. But this is the typical range. And in expected later this year, there's up to an $840 rebate for income qualifying families from the federal IRA rebates. Next slide. Heat pump dryers have a similar range, between 1,000 and about 1,700 is a typical range. And they also qualify for a IRA rebate expected later this year. As Jason mentioned, for dryers and stoves, traditional electric resistance options are also really valid. They can come at some lower price points, and they still have all of the health benefits that come with switching to electric. So if you're looking for some, lower price option, those can be good to explore as well. Next slide. With that, we'll jump into our last section, electrical panels and wiring. Over to you, Jason.
Thanks, Matthew. So what do we need to know about electrical panels as it pertains to electrifying appliances in our home? I'm going to go over some common terms associated with electrical panels and electricity more broadly. We'll look at the location, function, and components of our panels. We'll talk about how we can evaluate our electrical panel and our home's energy requirements, panel upgrade costs and ways we can work around those costs and perhaps avoid them. And if we can avoid them, the financial incentives that are available to sort of mitigate those costs. So how do electrical panels work? So here are some common terms many of you are probably familiar with associated with electricity, and I'll just go over them quickly. So we often hear about amps, volts, and watts, but what do they mean? And a good way to think about it is kind of this water analogy that you see in the graph image to the right-hand side. But it's easy to think about one easy way to think about it is amps are the current flow of electrons or electricity. Volts is the force or pressure that makes electricity move. And then watts is the power, the unit of power, the way we measure the output of the energy flow when all those work together. So what are electrical panels? And here, many of you, I'm sure, have seen the electrical panel in your home. They're gray steel boxes that hold circuit breakers. They connect to our utilities energy infrastructure and integrates that infrastructure with our home's electrical system. And importantly, they protect against power surges, and they allocate electricity via circuits throughout our homes. Here are some additional images of electrical panels. The one on the left is located outside, which is not common here. And the two other images are just common ways that you'll find electrical panels inside of your home. This image on the left-hand side is a sub-panel, and the right-hand side image is your utilities electric meter. So how do we locate your electrical panel. Many of you probably are already familiar with this, but they're typically located indoors near where the point near the point where the electricity enters the home. So where that utility electrical meter is located outside your home, typically your electrical panel is located inside the home, close to where that meter enters. They're typically located in utility rooms, basements, closets, or garage. And as I had mentioned in the previous slide, sometimes they can be located outside, but that's a little bit atypical for our location. So how do we find the size or capacity of our electrical panel? So the first step is to find the main breaker. Typically, this is going to be the largest switch, and it's usually at the top. Once you open the electrical panel door, it's typically at the top of your panel. It's usually labeled main or service disconnect, and your panel size or capacity in amps will be located on that switch, and we'll see an image in our next slide. So with the image on the left, you see an electrical panel. That switch that's highlighted there with the arrow is the main breaker, and the blow up image to the right, you can see on the switch there's the number 200 stamped onto the switch, and that indicates that this is a 200 amp capacity panel. So there are various components of electrical panel. We'll go over a few important ones. Again, the capacity of your panel, it's going to be designated as either a 60, 100, 150, or 200 amp panel. The other major component of your electrical panel is going to be circuit breakers, and they are designated in both their volts and amperage. A single pole breaker typically manages the electrical circuit for small appliances. A double pole breaker will manage 240 volt appliances, so your larger appliances like the ones we're talking about this evening. And breaker amps, the breaker amps on your circuit breakers can vary from 15 to 30 amps. And with the image on the right, you can kind of see how this plays out. When do you need a panel upgrade? So the two important factors that will play into whether or not you need an electrical panel upgrade is going to be your electrical space. That's if your panel's capacity in amps is not high enough to accommodate all of the electrical appliances they have in your home and your usage. The other would be the physical space, and that pertains to whether or not there are open circuit breaker spots that allows you to add additional appliances in your home. So what capacity panel do I need to electrify? So this slide here kind of shows you a general outline of the standard panel sizes that you'll encounter. If you have a 60 amp panel, it's likely you'll need to upsize, and we highly recommend that you consider upsizing to a 200 amp panel if you are going to do so. It allows you to future-proof your home and add additional appliances as you have other projects down the road. If you have an under 100 amp panel, it depends on your home and your goals. We'll look at a slide a little bit later where a 100 amp panel house has quite a few electrical appliances going on in that home with a 100 amp panel. With a 150 amp panel, you most likely don't need to upsize. And if you have 200 amps, upsizing is pretty unlikely for your home. Other considerations to think about with electrical panels is older homes may require you to have an upgraded service panel. Another issue would be if you have knob and tube wiring. That's in the image that you see to the right. That may mean that will necessarily mean that you'll have to run new wiring in your home for these for adding additional electrical appliances. And a common upgrade that you're going to see is going to be upgrading from a 100 amp panel to a 200 amp panel. So here's a few facts about panel upgrades. The median home with a 100 amp panel typically uses less than 50% of its capacity. The majority of homes that have a 100 amp panel, they never exceed that 100 amp capacity. But the one thing to consider is if you upsize from 100 amp to a 200 amp panel, again, that's going to enable you to be able to accommodate future electrification projects down the road. So how do we go about evaluating our electrical panel and whether or not we need an upgrade. So these are kind of the questions that you need to think about and be able to answer when you're evaluating your panel. What is my panel's current amp capacity? Again, you find that on that main circuit breaker. Uh, do I have available circuit breakers in the panel? And those will be vacant slots in your electrical panel. What are my current electricity needs? And we'll talk about how to sort of evaluate those and get a rough estimate of what those are. And what are my long-term plans going to be for electrification? So the primary way we suggest that you assess if you need a panel upgrade is by working with an electrician to to calculate your electrical panel's load. We'll go over some of the ways that you can do this here shortly. And electrician will generally follow these methods. If you're a go-getter and do it yourselfer, you can also try to do this on your own and sort of self-assess your electrical panel's load. So panel assessment, the first option, again, this is national code or national approved code, nationally approved way to go about figuring out the capacity and the load of your electrical panel. Little math involved. You're basically getting your annual electrical demand in kilowatt hours from your utility records, doing a little math and converting that to amps, and that will give you your maximum electrical demand in amps. Here is option 2, which also is another proved method of assessing your panel. We'll include links to these along with the slides when I send them out. But again, you're basically looking at what you have going on in your house in terms of electrical appliances and figuring out how much amperage you need and if your panel is able to accommodate that requirement. A third way to assess your home's energy panel is using the Redwood Energy's watt diet. It's a pretty neat way. It's a calculator. You can plug your home information into it. It'll give you a amperage of what your load is, and you'll be able to sort of assess whether or not you need to upgrade your electrical panel going forward. Here's the example that I mentioned before. This is a all-electric 100 amp house. Granted, this is in California, so the climate obviously is quite different. But as you can see on the left or the right-hand side, they got a lot of stuff going on. There's 4 occupants in this home. There's EV charging. They have a 60 to 80 gallon heat pump water heater, an induction stove. They also have EV charging, solar power. So there's a lot of stuff going on. And if you're creative and sort of going to this process with a plan, you're able to make it work on a 100 amp panel. So how can I avoid any electrical panel upgrades? Harkening back to our webinar, our first webinar, fundamentally the basic important thing that you can do is make sure that your home is air sealed and insulated properly. Make sure you have great windows. If you have single pane windows, get those upgraded to double pane, if not triple pane. All of these technologies reach their best efficiency levels when your home building envelope is sealed tight. You can also install efficient right-sized equipment. We always promote this when you're thinking about adding additional electrical appliances to your home. Kind of a low-hanging fruit that all of us are probably aware of is upgrading your home lighting to LEDs. You save a lot of energy there. Use energy efficient heat pumps and induction stoves, which we have talked about in this workshop, and choose power efficient versions of appliances regardless of what appliance you're getting. Another way to avoid panel upgrades is to optimize your circuit breaker space. One of these ways is to combine appliances. There's a lot of clothes, washer and dryer combos nowadays, as well as oven and cooktops that will share a circuit. Another way is to use circuit sharing devices. We have an example in the image on the right where an EV charger and a clothes dryer are plugged into the same circuit. The EV vehicle is charging When the dryer goes on, the EV charging is paused until the dryer is done. Then it can switch back to the EV charging. Automatic pausing units are pretty similar. You can also combine small circuits into a sub panel to open up space in your main panel. This doesn't impact your panel's capacity, but it does allow you to have more physical space to add additional appliances. And the same goes with adding tandem or slim breakers. They're more cost efficient, space efficient circuit breakers that you can add to your panel, and it just opens up additional physical space. So what do I need to ask contractors? A contractor should be able to tell you what your be able to answer the question of, does my panel have the capacity for this appliance or equipment upgrade? What if I want to do additional appliances in the future, and add additional appliances? How will that impact my panel? And how does the contractor go about assessing your panel's capacity? Contractors should not say that they assess your panel's capacity by your home square footage. They also shouldn't say, I've been in this industry for 30 years and I kind of use a rule of thumb guesstimate to figure out what size of panel you'll need. They should be following one of these criteria that we had mentioned earlier in the presentation. So what are the costs and incentives? So electrical panel upsizing costs. Panel upgrade could cost anywhere from $1,000 to $6,000. It depends quite a bit on what you need. The wiring can be $800 to $1,500 per circuit, and retrofitting a home for 240-volt electrical appliances may require running new wires, which would be an additional cost. The time can vary quite a bit depending on the circumstance, but generally weeks to months. It depends a lot on the availability of electricians. And incentives to sort of mitigate those costs if you can't get around upsizing. Like we mentioned earlier, there's an XL energy rebate available. There's some federal tax credits. There's an expected rebate at the federal level that's expected in 2025. State of Minnesota offers a $3,000 grant that hasn't been announced yet. But and then just for the electrical wiring upgrades, there's also a federal incentive, $2,500 rebate, which is expected in 2025. So in summary, so do I need to upsize my panel? You should base this on your plans and your existing panels. So again, if you have a 60 amp panel, you're going to need to upsize to add some of these electrical appliances. And we would recommend just going ahead and doing a 200 amp panel. It's going to future-proof your home, and it's going to accommodate any projects you have down the road. 100 amp panel, you're going to want to go through one of those three options that we had mentioned about assessing your panel. If you're planning to do a full electrification of your home, it may be worth upsizing to a 200 amp panel right away. If you're doing a partial electrification, it might be more likely to use some of those strategies that we talked about to avoid the upsizing. If you have a 100 amp panel, most likely you don't need to upsize. And again, if you have a 200 amp panel, that's great. Your upsizing would be unlikely. I'm going to pass it to Matthew to sort of round us up, talking about resources to help us electrify.
So thanks, Jason. And yeah, while these are up on the screen, we'll get our Q&A session started here. So if you have any questions you'd like to discuss, please throw them in the chat and we will answer them right after this. And I just wanted to let you all know that thanks to the city of Prairie residents and others can contact the Electrify Everything advisors for free to get free advice on installing any of the upgrades we talked about today. Getting a home energy squad visit is also a great way to learn about your home, especially your water heater's age and health. And then for finding a contractor, the heat pump water heater installer network is a great resource. So with that, we'd love to hear your questions, and I'll start with Fred's question about induction cookware. And the question was, we found that the induction range pans are too heavy for an older person with weak wrists. Are there lighter pans available? And I know from experience, cast iron is really heavy. So are there lighter options? And the short answer is yes, there are a lot of steel cookware with ceramic coating that's pretty lightweight. Maybe not quite as light as aluminum, but definitely a lot lighter than cast iron. And there are a lot more induction cookware options on the market today than there were even a couple years ago. All right. Well, I know we're at the top of the hour here, so anyone who needs to jump off, feel free. We will stick on and answer more questions. And I just wanted to give a big thank you to the City of Eden Prairie for sponsoring this webinar. This program isn't possible without our city partners, and we are really grateful for them. So thanks, everyone. Let us know if you have any questions, and appreciate you spending your evening with us.